Hello everyone, welcome to our presentation. Our project is titled Nimbus, a national blockchain-driven private cloud-based platform for Bangladesh adopted in land administration. Our team is Duo Nimbus, myself Tahlil, Ishtiaque, Zahid, Mohammad, Atiquer, Rahman and Mohammad Sohrawardy. In the world map, you can see here the large country is Russia and the green dot inside the circle is Bangladesh, where we are from. Although Bangladesh is 115 times smaller than Russia, it has 20 million more population. Hence, the land fragmentation is also high. On top of that, Bangladesh mostly uses a paper-based land administration system. Current system is inefficient and corrupted, as Transparency International found that each year Bangladesh land administration system generates more than 25,000 million Bangladeshi taka in black money. Furthermore, the current service is stressful, where each deed takes up to 3 months to get registered. This is the current process of transfer of land in the land administration of Bangladesh. It requires 3 months to register each transfer deed. This involves, as we can see, 3 land administrative intermediaries on local level excluding the bank to do a single transaction. And also each steps take physical intervention. So a nimble solution is necessary. Hence, presenting Nimbus. Nimbus is a national blockchain-driven private cloud-based platform. Nimbus ensures each registration can be done within a single day. It streamlines the process with just one local intermediary, the sub-registry. If a buyer wants to buy a land, he logs into the web app. He can easily verify the ownership of the land he wants to buy from the app. The buyer and seller come to an agreement by communicating with each other in a secure P2P channel through the app. They both have to fill a simple contract and the transaction request is sent to the sub-registry through the land ministry's approval. The buyer and seller go to the sub-registry. There, the sub-registry takes biometrics of the buyer and seller and validates the transaction. Upon verifying, payment request is sent to the corresponding buyer and seller bank. Their balance is changed accordingly. Then, confirmation is sent by the bank. The new transaction is broadcast in the network and added to the blockchain. The simple contract ensures the integrity of the transaction and both buyer and seller needs only one physical step. Blockchain-based Nimbus outmatches the current manual process and even a centralized digital system in many aspects. Nimbus helps to keep exact same record at all places and ensure fast processing. It is more secure than both centralized and manual system because cryptographically signed and intemperable records are stored in blockchain. Since the copy of the distributed ledger is stored throughout the network and there is no single point of attack, Nimbus is more secure and available than a centralized system. Also, unlike the other two solutions, Nimbus can ensure transparency and privacy for end user for doing land transaction. The Nimbus was designed in considering the following requirements. It is built using permissive open source platforms because it is incompatible with many countries' law to store government info to third-party cloud service including Bangladesh. The blockchain platform is also designed accordingly to have fast query from the distributed ledger and to hold high volume data with high throughput without compromising security. As part of technical architecture, BigchainDB is used as a blockchain as a service platform, which is a scalable blockchain database designed to merge the best of two worlds, the traditional distributed database world and the traditional blockchain world. The BigchainDB blockchain is set up and managed through the BigchainDB server's Node.js API. The core adapted consensus component is tailor-made. It is a Byzantine fault-tolerant consensus protocol that ensures complete secure addition of block even 1/3 of nodes are compromised. The blocks are stored on MongoDB instance following BigchainDB 2.0 version that ensure powerful indexing and querying capabilities. Then, simple contracts are BigchainDB compatible pieces of code that can run automatically but linear in structure and have permission mutable property unlike the traditional smart contract deployed in Ethereum or Hyperledger. And finally, the cross-platform application for the end user is developed using JavaScript framework Ionic with capacitor backend, so both the desktop and mobile app can run from a single code base. In the private cloud architecture, OpenStack ecosystem is used. The version of OpenStack used is the OpenStack Newton, which is the latest stable version. To set up the entire cloud platform, some additional service components is needed to be installed, namely for identity service Keystone, for distributed file service Manila, for networking service Neutron. The OpenStack software and its components are installed in the virtual Ubuntu live server images regardless of the underlying operating system. For deployment purpose, Ansible software is used. And there is web-based OpenStack dashboard called Horizon that helps to monitor and manage all the services and APIs that OpenStack provide. All these technologies are fully open source, so government can avoid vendor login and regulatory compliance is easier to inaugurate and adopt. Also, OpenStack is one of the top 3 most active open source projects and manages 10 billion computer cores worldwide. So there is a strong community backup, which ensures better troubleshooting. This diagram highlights the governance system of the Nimbus platform in the context of Bangladesh. The office is responsible for the administration in each upazila or sub-district represented as orange boxes, and the Ministry of Land represented as a purple box makes up the private cloud. The blockchain is of public permission type. The nodes hosted on the on-premise private cloud are the supernodes, and the devices of the consumer the application is installed on are the light nodes. Supernode contains the entire copy of the distributed ledger, while the light ones only a subset of it. The supernode, also the founding member, have both read and write permission. The peers, who are the end user, have only read permission. The privacy of the end users are protected using homomorphic encryption, which works by processing encrypted requests without decrypting it.
Nimbus has significant social and economic value. First of all, it will reduce time and hassle for the users. At present, registering a deed takes up to 3 months and Nimbus would take less than 3 days. It will eliminate bribery. According to Transparency International Bangladesh, every year a user pays $135 in bribe. In total, $297 million a year. Nimbus would legitimately charge less than $5 each year. And also, Nimbus will eliminate the middlemen involved here. All these advances are to attain Sustainable Development Goal number 16 by reducing corruption and increasing transparency. Nimbus also generates high economic value, and it has a sustainable business model and identifiable market segment with growth potential. Let's look at the market now. With Nimbus, we are looking at a large potential market. The first customer segment are the individuals who can buy, sell, advertise, pay taxes and maintain their land through Nimbus. National Household Survey suggests that 6.5 million Bangladeshi households uses land administration services each year, and our analysis shows that 4.04 million deeds will be registered per year by 2026. For the corporate segment like banks, Nimbus offers verification and mortgage status services, which is manual now. Central bank data shows that 64% of bank loan, and our primary analysis shows that 90% of microfinance loans are taken using land deed as collateral in Bangladesh. For Nimbus, land administration authorities will be the partner for operation and maintenance, while financial intermediaries will be partner for transaction and collection, and National ICT Ministry will be the partner for validation and information. And finally, licensed intermediaries will be used as implementation and other support partners, which can also be used to adapt Nimbus in a certain country system. As our financial projection suggests, majority of the revenue for Nimbus would come from subscription fee, deed registration fee from the individuals, and mortgage status request fee from the corporates. Majority of the cost will be for salary expenses, office expenses, and marketing, communication, awareness, and training expenses. As a financially sustainable project, Nimbus requires an investment of $1.72 million over 3 years, and it would generate positive cash flow from 3rd year of operation. Please see appendices of the PDF deck for more. As Nimbus will be owned by the government, there will be no direct competition. Here we see the Nimbus model. If the digital interface of Nimbus becomes too difficult for the users, there might be intermediaries who would make Nimbus costly for the users. We suggest a contingency plan of proper awareness and training programs, and also government-managed digital centers in the rural area to make it available for the users. There are other risks Nimbus might face. Implementation risk would come from digitizing the records, and also if the current intermediaries protest. Here we have to ensure transparency while digitizing records that are currently manual. There are technical risks that might arise from offering technical duties to officers who worked in manual system before. Proper training and establishing biometric or reliable authorization system will be crucial. Finally, there are operational risks of land dispute and attempts of fraud. There should be proper testing, parallel system run, and also mechanism to show dispute status. Geotagging can be used to establish land boundary in the system. Looking at timeline distribution, in the initial year 2021, we shall finalize our prototype and test the system on a small scale with iterations. In the meantime, record digitalization would go on. Then the next year, we would deploy it in 5% of land areas in Bangladesh and prepare for wide implementation. In the third phase, we shall set up the system and train the officials by the end of 2023. Finally, from the beginning of 2024, Nimbus would be online throughout Bangladesh with a maintenance framework. In conclusion, Nimbus offers a nimble, secure blockchain-based solution to the inefficient manual land system in Bangladesh. It offers a robust architecture that supersedes regular digital system and presents a unique blockchain solution. With significant social value tied to the Sustainable Development Goals, it also has huge market potential, and the risks that it has can be reasonably managed by suggested counter strategies. Hence, we confidently propose Nimbus land administration for the citizens, for whom land is an asset, investment, and source of livelihood.